On a warm summer evening in 1981, hundreds of people gathered inside a hotel atrium in Kansas City. They came to dance, to listen to music, to stand on walkways designed for nothing more than observation. Above them, the structure looked solid, permanent, unquestioned. There were no alarms, no visible cracks, no sense of danger. What almost no one in the room knew was that a small change, approved months earlier and barely discussed, had already turned the building into a trap. In less than 20 seconds, the space meant to bring people together would become one of the deadliest structural failures in American history. Before the collapse, the Hyatt Regency Hotel in Kansas City was considered a modern and impressive space. Opened in 1980, the hotel was designed to feel grand and welcoming, centered around a large atrium that rose several stories high. Suspended walkways crossed the open space, allowing guests to look down into the lobby below. These walkways were not decorative features. They were functional pedestrian bridges, meant to handle regular foot traffic during busy events. From the outside, nothing about the design appeared unusual or unsafe. The hotel quickly became a popular venue for conferences, social gatherings, and public events. On the evening of July 17, 1981, the atrium was filled with people attending a dance competition. Guests gathered on the ground floor, while others stood along the railings of the walkways above, watching the event below. The atmosphere was relaxed and celebratory. There was no sense of danger. What most people did not know was that the walkways overhead had already undergone a critical design change during construction. The original engineering plans called for a continuous steel rod system that would support both walkways independently. However, during the construction phase, this design was altered. Instead of using one continuous rod running from the ceiling through both walkways, the final design used two separate rods. One supported the upper walkway, and a second rod connected the upper walkway to the lower one. On paper, the change appeared minor. In reality, it doubled the load placed on the connections holding the lower walkway. This modification was not accompanied by a full structural recalculation. The altered design was reviewed and approved through routine channels, without triggering alarm. No one involved believed they were making a dangerous decision. Each step followed standard procedures. Engineers, fabricators, and inspectors assumed that someone else had verified the safety implications. The result was a system that met expectations on the surface but carried a hidden weakness. As the building was completed and opened to the public, the walkways performed as expected, reinforcing the belief that the design was sound. For months, nothing happened. No visible signs of stress appeared. The structure seemed stable. This period of normal use created a sense of confidence. By the summer of 1981, the hotel had hosted numerous events without incident. That sense of normality would later become a crucial factor. Because the walkways had not failed immediately, the underlying problem remained invisible. The danger was not dramatic or obvious. It was silent, embedded in steel connections that were assumed to be adequate. On the night of the dance competition, people leaned casually against the railings. Others paused briefly on the walkways, talking or watching the activity below. The load on the structure increased gradually, not suddenly. There was no single moment that signaled imminent failure. The walkways were doing exactly what they had always done, and that was precisely what made the situation so dangerous. The conditions that would lead to disaster were already in place, hidden within a design decision that seemed reasonable at the time and went unquestioned once the building was complete. The collapse of the Hyatt Regency walkways did not begin on the night of the event. It began months earlier, during design and construction, in decisions that seemed routine at the time. The atrium was an ambitious architectural feature, and the suspended walkways were central to its design. The original engineering plans called for a continuous steel rod system. Each rod would run from the ceiling, pass through the upper walkway, and continue down to support the lower walkway independently. This ensured that the load from each walkway would be carried directly to the roof structure. During construction, however, this design was changed. The steel fabricator proposed an alternative that appeared simpler to build. Instead of one continuous rod, the revised design used two separate rods. One supported the upper walkway, while a second connected the upper walkway to the lower one. On the surface, the change seemed minor. It did not alter the appearance of the structure and did not immediately raise concerns. What was not fully recognized was how this modification changed the way forces were distributed. In the revised design, the lower walkway was no longer supported independently. Its weight was now transferred through the upper walkway connections, effectively doubling the load they were required to carry. The problem was not the strength of the steel rods themselves, but the connection details, which were never designed for this increased load. Despite this, the revised drawings were reviewed and approved. Communication between the engineering firm and the fabricator was incomplete, and assumptions replaced careful verification. Each party believed the other had checked the calculations. This was not a single reckless act, but a chain of small oversights. Once installed, the walkways appeared stable. There were no visible signs of distress, reinforcing the belief that the design was safe. In reality, the structure was operating with almost no margin of safety. The vulnerability was hidden inside the connections, out of sight and out of mind. By the time the hotel opened, the conditions for failure were already in place, created quietly through miscommunication and a design change that seemed harmless but proved catastrophic. After the hotel opened, the walkways quickly became a normal and accepted part of the building. Guests crossed them daily without hesitation. They were used during conferences, social gatherings, and public events, blending seamlessly into the routine of hotel life. Nothing about their appearance suggested danger. The steel rods and connections were hidden within the structure, invisible to guests and staff. Even trained professionals had little reason to question them once the building was completed and approved. Inspections focused on visible elements and code compliance, not on revisiting design assumptions that had already been signed off. As months passed without incident, confidence grew. The walkways had carried people many times before, reinforcing the belief that they were safe. This sense of normality was deceptive. Structures do not fail only when overloaded. They also fail when they are asked, repeatedly, to perform near their limits. Each event added small, cumulative stresses to the connections, stresses that were never intended to be there. Because the revised design had eliminated the safety margin, there was no buffer for these everyday loads. Still, there were no clear warning signs. The connections did not visibly bend or crack. No alarms were triggered. The danger remained silent and internal. On the evening of July 17, 1981, the atrium was busier than usual. A dance competition drew a crowd, filling the lobby with spectators. Some guests gathered on the walkways above, leaning casually against the railings, watching the activity below. The additional weight was not extreme. It was well within what people assumed the structure could handle. This assumption was reasonable, based on experience. The walkways had held before, but the structural reality was different. The load on the upper walkway connections increased gradually as people shifted positions and gathered along the railing. This load was transferred directly to the already overstressed connections supporting the lower walkway. There was no single dramatic moment that signaled imminent failure. No loud warning, no visible movement. The structure reached its limit quietly. When failure came, it was sudden and total. The connections gave way almost simultaneously, releasing the upper walkway. It fell directly onto the lower one below. In an instant, both walkways collapsed, dropping into the crowded lobby. The collapse lasted only seconds, but the forces involved were enormous. Steel components tore apart, concrete shattered, and the open atrium became a scene of devastation. What made the event especially shocking was how ordinary everything had seemed moments earlier. There had been no warning that disaster was about to strike. The collapse was not caused by misuse, panic, or reckless behavior. It was the inevitable outcome of a structural weakness that had gone unnoticed and unchallenged. In the aftermath, it became clear that the failure was not the result of a single action on that night, but of decisions made long before, embedded into the structure itself. waiting silently for the conditions that would expose them. In the moments immediately after the collapse, the atrium was transformed from a place of celebration into one of confusion and shock. Dust filled the air, and the sound of music was replaced by shouting and silence in uneven bursts. Many people did not immediately understand what had happened. From the ground floor, it was unclear where the structure had failed or whether more parts of the building were at risk. Those who were not injured began searching instinctively for friends and family members, calling out names in the dimly lit space. The fallen walkways formed a tangled mass of steel, concrete, and bodies, blocking movement through the lobby. Emergency responders arrived quickly, but access was difficult. The debris was heavy and unstable, and there was concern that additional structural elements could collapse if disturbed. Rescuers worked cautiously, often by hand, lifting pieces of metal and concrete to reach those trapped beneath. The scale of the damage became apparent only gradually. What had appeared moments earlier as a simple architectural feature now lay compressed into a dense pile several feet high. Survivors were pulled from narrow voids within the wreckage, while others were found pinned beneath the weight of the structure. As hours passed, the initial chaos gave way to a more controlled rescue effort. Temporary lighting was brought in, and the atrium became a work site rather than a public space. Engineers and inspectors were called to assess the stability of the surrounding structure, ensuring that the remaining parts of the building posed no immediate danger. Outside the hotel, families and onlookers gathered, waiting for information. Inside, the focus shifted from rescue to recovery. By the end of the night, the human cost of the collapse was becoming clear. The event was no longer just an accident inside a hotel atrium. It was a mass casualty incident that demanded explanation. Almost immediately, questions began to surface. How could a modern building, recently constructed and approved, suffer such a catastrophic failure? Why had there been no warning signs? As the immediate emergency subsided, attention turned away from the wreckage itself and toward the decisions that had shaped it. The collapse was over, but understanding it had only just begun. As rescue operations continued and the full scale of the tragedy became clear, attention began to shift toward understanding why the collapse had happened. Almost immediately, engineers and investigators recognized that this was not a random accident. Modern buildings were not supposed to fail this way, especially ones that had been recently constructed and approved. The focus quickly narrowed to the suspended walkways themselves. Structural engineers examined the debris, documenting the broken connections and the manner in which the steel components had failed. What they found pointed away from overloading by the crowd and toward a fundamental problem in the design. The critical evidence lay in the steel rod connections that had supported the walkways. These connections showed clear signs of being subjected to forces far greater than they were designed to handle. As investigators reconstructed the original design and compared it to the as-built structure, the design change made during construction became central to the investigation. The shift from a continuous rod system to a two-rod configuration fundamentally altered how loads were transferred through the structure. What had once been independent load paths were now dependent on a single set of connections. This discovery raised an uncomfortable question. How had such a significant change been approved without a full structural review? The answer was not straightforward. Responsibility was spread across multiple parties, including the engineering firm, the steel fabricator, and those responsible for reviewing and approving the modifications. Documentation revealed that communication between these groups had been fragmented and informal. Design drawings were exchanged, but the implications of the changes were not fully discussed. Calculations that should have been revisited were either assumed to be correct or never completed in detail. Each party relied on the expertise of the others. This reliance created gaps where critical checks should have occurred. No single individual set out to cut corners or ignore safety. Instead, the failure emerged from a system in which assumptions replaced verification. The investigation also revealed that building codes at the time did not require engineers to reanalyze every design modification in detail, especially when changes appeared minor. Compliance with existing standards had been treated as proof of safety. In this case, it was not enough. As findings accumulated, it became increasingly clear that the collapse was not caused by the people who had gathered in the atrium that night. It was the result of decisions made long before, embedded in drawings, approvals, and professional judgments that had gone unquestioned. The investigation was moving toward a conclusion, but the implications of that conclusion would extend far beyond the Hyatt Regency itself. As the investigation progressed, attention turned from what had failed to who was responsible. This phase proved far more complex than identifying a broken connection. Multiple organizations were involved in the design, fabrication, and approval of the walkways, and each had played a role in the sequence of decisions that led to the collapse. The engineering firm had approved the revised design without performing a full structural analysis. The steel fabricator had proposed the change, focusing on constructability rather than load behavior. Review processes existed, but they relied heavily on trust and professional assumptions rather than independent verification. No single document showed clear negligence. Instead, responsibility was distributed across a system that allowed critical decisions to pass without challenge. Professional licensing boards became involved, examining whether ethical standards had been violated. Engineers are bound by a duty to protect public safety above all else, even when under pressure from schedules or budgets. In this case, investigators concluded that this duty had not been adequately upheld. The design change should have triggered a detailed reanalysis, regardless of how minor it appeared. The fact that it did not revealed a deeper problem within professional practice at the time. Engineering decisions were often treated as internal matters, shielded from external scrutiny once approved. The legal response reflected this complexity. Lawsuits were filed against multiple parties, but assigning blame proved difficult. Settlements addressed financial responsibility, yet they did little to clarify accountability. For many families, compensation could not replace answers. What emerged instead was a growing recognition that the failure was not just technical, but cultural. It exposed how professional norms, communication habits, and institutional structures could combine to produce catastrophic outcomes without any single malicious act. The Hyatt Regency collapse forced engineers, regulators, and professional organizations to confront uncomfortable questions about how safety was evaluated and enforced. It was becoming clear that preventing future disasters would require more than stronger materials or better calculations. It would require changes in how responsibility itself was understood and exercised. As the legal cases concluded and professional reviews were completed, the impact of the Hyatt Regency collapse began to extend beyond the hotel itself. Engineering organizations, licensing boards, and academic institutions were forced to confront what the failure revealed about professional practice. The collapse demonstrated that compliance with codes and procedures was not enough when critical decisions were treated as routine. In response, professional engineering societies began revising standards related to design changes and communication. Greater emphasis was placed on clearly defining responsibility for reviewing and approving structural modifications. Engineers were reminded that even small changes could have significant consequences and that assumptions could never replace calculation. Licensing boards strengthened ethical guidelines, reinforcing the principle that public safety must remain the highest priority, regardless of project pressure or organizational hierarchy. The Hyatt Regency collapse also changed how engineering failures were taught. Universities incorporated the case into curricula, not as an example of technical complexity, but as a lesson in communication, responsibility, and professional judgment. Students were taught that failures often arise not from a lack of knowledge, but from gaps between roles, unclear accountability, and the normalization of risk. Beyond engineering, the collapse influenced how large public spaces were evaluated and managed. Building owners and inspectors became more cautious about suspended structures and non-standard designs. Review processes were adjusted to require clearer documentation and verification when changes occurred during construction. The disaster also left a lasting mark on those directly affected. Survivors and families continued to seek answers long after legal proceedings ended, reminding institutions that technical explanations could never fully address human loss. Over time, the Hyatt Regency collapse became a reference point, cited whenever questions arose about professional responsibility and systemic failure. It was no longer seen as an isolated accident, but as a warning about what can happen when systems allow critical decisions to pass without challenge. The building itself could be repaired and procedures could be updated, but the deeper lesson was harder to implement. It required a shift in mindset, one that recognized that safety depends not only on design strength, but on vigilance, communication, and the willingness to question assumptions before they become permanent. Today, the Hyatt Regency Walkway collapse is remembered not only for the scale of the tragedy, but for what it revealed about how failures occur. It showed that disasters do not always begin with obvious danger or dramatic warning signs. More often, they emerge quietly, through routine decisions, accepted assumptions, and systems that discourage questioning. The walkways did not fail because of an extraordinary event. They failed during normal use, under conditions that should have been safe. This fact remains central to the lesson the collapse left behind. It challenged the idea that responsibility can be divided without consequence. Each individual decision involved in the project seemed reasonable when viewed in isolation. Taken together, they created a structure that no longer had the capacity to protect the people who trusted it. The collapse forced a broader reconsideration of how safety is managed in complex systems. It highlighted the danger of relying on informal communication, incomplete reviews, and professional trust without verification. Over time, the case became a reminder that technical expertise alone is not enough. Safety depends on culture, accountability, and the willingness to slow down when uncertainty appears. The victims of the collapse are often remembered in statistics, but their presence continues in the changes that followed. Every design review that demands clarification, every calculation that is rechecked, and every assumption that is challenged reflects a lesson paid for at a high cost. The atrium where the collapse occurred has long since been rebuilt, and the hotel has changed hands and names. Yet the questions raised by the disaster still resonate far beyond that space. They ask how modern systems balance efficiency with caution, and how responsibility is maintained when decisions pass through many hands. The Hyatt Regency collapse endures not because of how suddenly it happened, but because of how easily it could have been prevented, and how important it remains to remember that safety is never guaranteed by design alone.